Okay, you're all welcome once again. I want to take you guys through the belt drive system. Alright, so in the belt drive system, we have a pulley that is running another pulley, or a pulley driving another pulley using a belt. So let me draw the belt around it. So ideally, we have the belt touching the tangent here, and then the tangent here. So the belt runs this way, right? So suppose this one is clockwise, this one also be what? Clockwise. Suppose assuming the belt is wrap around it in this direction. Now, there are certain things I want you guys to pay attention to before we move on. So with the pulley 2, if it's turning around, it pushes the belt along, and when the belt gets here, the belt pushes on the pulley 3 to also what? Turn around. Now, before I go to the velocity aspect, I want you guys to understand what we mean by wrap angle. So this part of the belt wraps around pulley 3 up to this point, and then it leaves pulley 3. When you get here, it starts wrapping pulley 2 from this point up onto this point. So it looks like we form a chord from this point up to this point. So the angle subtended at the center by the chord here, which is the angle here, theta, is what we call what? Wrap angle. Similar to this, with pulley 2, you have from the points where the line touches the circle at this point, and then up to this point where the wrap makes an angle at the center, which is this one. So what we have here and what we have here is what we call it was wrap angle. Now let's understand the velocity transmission. So if I have this pulley turning this around, this could be a source, it could be connected to a crankshaft or electric motor. So if it's making this pulley turn around, it's going to generate a tangential velocity at the end here, right? Or end here, at the circumference. So the velocity V will be equal to omega 2 R2. You understand? Now this V will be the velocity on the belt, right? Velocity V. Now the V, when you get here, it will turn this one also around. So let's look at the ideal situation. So the velocity here is the velocity produced by what? Omega 2 R2. When you get here, that velocity should be the same at this point. So we say velocity is also equal to what? Omega 3 R3. Right, since they are the same, we can equate them and then find the angular velocity ratio. So omega 3 R3 is equal to omega 2 what? R2. This means omega 3 over omega 2 is equal to R2 on R3. I make the omega 2 come here and R3 comes here. Right. Now, there is something about slip that we need to talk about. But before I go to slip, you realize that the radius is for a circular path that is center is perforated. It's hard to get an accurate measurement for the radius. So we can choose to use what? Diameter, which is to say that if I multiply top and down by 2, this and this can cancel and nothing happens, right? So 2 times R2 will be D2, and 2 times R3 will be what? D3. So equally, we can use the ratios of the diameters when we looking for the ratios of the velocity. Another thing you should pay attention to is that I am looking for, so this is a driver pulley and this is a driven pulley. So if I'm looking for the angular velocity of the driven pulley, which is omega 3, it should be velocity of the driven over angular velocity of the driver. So we know the angular velocity of the driver, looking for what? The driven. That should be equal to the diameter of the driver, which is 2, all on diameter on what of what? The driven, which is similar to what we have here. So this is what we have. Okay, now I want us to talk about slip. Okay, slip. Now, the transmission of the velocity to the belt relies on friction, the friction between the belt and then the surface of the pulley. So in the case where friction, friction is limited, right? So there can be a situation where the friction is not enough to transmit all the translational velocity produced by omega 2 R2 to the belt. That means portion of the omega 2 R2 will be wasted in slipping the belt on top of the pulley. So if that's the case, then the velocity that is reaching the belt will be equal to omega 2 R2 produced minus the component that goes into what? The slipping, which is omega 2 R2 times what? The slip percent. So let's say S2 on 100. Right, so this means the velocity is equal to omega 2 R2 into brackets 1 minus what? S2 on 100. Right, if that's the case, then okay, so this is the velocity that is reaching the belt, right? So when this velocity reaches this point, it's supposed to turn the pulley around so that the pulley will also produce the same velocity, but which is what we've stated here, right? That V should be equal to omega 3 R3. But this velocity, because of slip, it can't be able to transmit all of it to omega 3 R3. That means part of the velocity coming from the belt to turn this one around will be used to will be used in slipping, which causes that inefficiency. So you're going to take the component of the velocity that is used in slipping when it's trying to turn this one around. So omega 3 R3 will be equal to what? The velocity coming minus the velocity, the component that goes into slipping. You understand that? That means our omega 3 R3 will be equal to what? Velocity into brackets 1 minus S3 on 100. Now the velocity we know, the velocity coming, which is V, is equal to what? Omega 2 R2 1 minus S2 on 100. So omega 3 R3 will be equal to what? Omega 2 R2 into brackets 1 minus S2 on 100, which is for V, times what? 1 minus S3 on 100. That means for this, when we are accounting for slip, now you see we have this omega 3 R3, omega 2 R2, which is similar to what we had here. So we can deal with that. The only thing here is that we have the slip here. So omega 3 on omega 2 will be equal to D2 on D3 multiplying 1 minus S2 on 100 multiplying 1 minus S3 on 100. Understand that? So the difference here is that we are multiplying this 1 minus the slip of the driver pulley and then multiplying 1 minus the slip of the driven pulley. Okay, now the other thing that I have to talk about is that if the belt has some thickness, we will add the thickness to the diameter, right? So the maximum transmission is done at this point, where at the point where this point is where the maximum speed is transmitted. So we add the thickness to the diameter of the pulley. So you have omega 3 on omega 2 is equal to what? D2 plus thickness all over D3 plus what? Thickness multiplying 1 minus S2 on 100, 1 minus S3 on what? 100. Right, so this is the formula. So if I know the input velocity and I want the output velocity, it should be equal to the driven, so if I'm looking for the driven velocity over the driver, it should be equal to the driver diameter all on the driven diameter multiplied by 1 minus the slip of the driver, which is in percentage form, all multiplied by 1 minus the slip of the driven. Okay, so that is that. Another thing is sometimes it will not show like this, right? It will not show like this. They will turn it around like that. So what we see is something like this. So okay, so let's say it is like if you're driving like this and then like that, and you're looking at it this way, this is what you can see. Sometimes it what can be turned around like that. If it turns around like that, this is how you are going to view it. So you have the pulleys here and the belt here, right? And then another pulley. So this is pulley 2, this is what pulley 3. The same concept, so you don't have to get confused when it comes to that. All right, so that is that. Now let's see how we can transfer our information here. So for belt drive, that a compound belt drive system, let me say that. So for that, we have belt 2 driving belt 4, and then belt 2 driving belt 3, and belt 4 driving pulley. We have gear pulley 2 driving pulley 3, and pulley 4 driving pulley 5. So there is a thickness here. So thickness of first belt, thickness of second belt. So from our understanding here, from 2 to 3, this is the driver pulley, this is the driven pulley. So omega 3 on omega 2 will be equal to D2 plus thickness of first belt, all on D3 plus thickness of first belt, multiplying 1 minus S2 over 100, 1 minus S3 on what? 100. But we know that this pulley and this pulley are on the same shaft. So omega 3 is equal to what? Omega 4. Now we know omega 4 is driving pulley 4 is driving pulley 5. So if you are looking for velocity of 5, angular velocity of 5, knowing angular velocity of 4. Okay, so we didn't talk about the turning, but since they are wrapped this way, they're going to be in the same direction. Now I will do that in a bit. So omega 4 and omega 5 and omega 4, because what the driver is here, right? So the diameter of the driver will come up. So D4 plus thickness of the second belt, all over D5 plus thickness of second belt, 1 minus S4 on 100, 1 minus what? S5 on 100, which means omega 5 is equal to what? Omega 4 D4 plus T thickness of this second belt, D5 plus thickness of second belt, multiplying 1 minus S of the 4th gear, the slip, 1 minus the slip on the 5th pulley. Sorry, I said gear. Now omega 4 is the same as omega 3, and omega 3 is the same as what? Omega 2 times the whole term here. So we can say omega 5 is equal to omega 2 multiplying D2 plus thickness of first belt, all over D3 plus thickness of first belt, multiplying this term. So let's put them there. So 1 minus S2 on 100, 1 minus S3 on 100, all multiplying D4 plus thickness of second, all over D5 plus thickness of second, all multiplying 1 minus S4 on 100, 1 minus S5. So you know omega 5 on omega 2 is equal to D2 plus thickness of first belt, all over 100, all over D3 plus thickness of first belt, D4 plus thickness of second belt, all on D5 plus thickness of second belt, multiplying 1 minus slip of 2 on 100, 1 minus slip of 3 on 100, 1 minus slip of 4 on 100, and 1 minus slip of 5 on 100. So if we have this compound, right? So if I'm looking for omega 5, knowing omega 2, from this pulley to this pulley, omega 5 and omega 2 is going to be driver diameter over driven diameter, or multiplying driver diameter over what? Driven diameter. The diameters, if the belt is has some thickness, you account for that. Now if this has thickness, if it has slip, you multiply that ratio, the ratio D2 on D3 multiplying D4 on D5, you multiply by the slip of what, 2 and a slip of 3. Now then, if it is moving, if it is just the 2, that would have ended it. But here you have another one here, so driver on driven, driver on driven. So you have this general equation. Thank you. In the next video, we are going to solve some questions using this. Now here, let me talk about the different motions. So you see here, the belt is not crossed, right? So if the belt is moving in this direction, it's going to turn the pulley around like that. So this one will move in the same direction. But suppose this one is moving this direction, I want this one to go the opposite direction. I will let the belt pass here, touch it, so it will come here and then go this direction. So if this one is turning around like that, you're going to call this one. Let's look at it from this. So if it's turning this way, the belt should be tensioned along this side. So it's trying to pull the belt, right? So if it pulls it, it's going to turn it like this. So you're going to make this one move this direction when it is moving this direction. So it's going to pull the belt like this. So as it's pulling, this one will be going this way, and then this one will be going this way. So if the belt is crossed, you have the motion was changing directions. So for that, the only difference is that the velocity on this one is omega2 r2. The velocity on this one will be negative omega2 omega3 r3, because the omega2 will be the negative of what, omega3, because they move in the opposite direction. Clockwise for this, counterclockwise for that. Thank you for watching. Kindly subscribe and like the video.